Hello students, in this video we will be studying about kinematic equations for uniformly accelerated motion, and sometimes they are simply known as equations of motion. So today we will study about these motions and how these can be derived. Okay, so there are four equations of motion. First I am just writing the equations. First is v is equal to u plus at. Second, s is equal to ut plus half a t square. Third is v square is equal to u square plus 2as. And fourth is s nth. Now this fourth one is actually the modified version of the second equation of motion. So sometimes in few books or in general conversation we say that there are only 3 equations of motion, or sometimes we say there are 4 equations of motion. So this fourth one is optional. This is the modified version of second equation of motion, and it is s nth is equal to u plus a by 2n minus 1. So these are the 4 equations, and now we are going to derive these 4 equations one by one. So let's begin with the first one. So to derive these equations, we are considering an object moving with constant acceleration along positive direction of x-axis. So we are considering a situation like this. This is the direction of positive x-axis. This is origin. An object is moving with constant acceleration small a along this direction from this to this point. Okay, so this is the point when the object is at 2 is equal to t is equal to 0. टाइम 0 पे ये पोजीशन थी ऑब्जेक्ट की, एंड आफ्टर टाइम t it come to point this. I am naming these points as a and b. So the object is moving from a to b in time t. So here t is equal to 0, while at the final position b t is equal to t. The initial velocity means the velocity at the time t is equal to 0 is u, while the final velocity is v, and acceleration throughout the motion is constant and is a. So this is what we are considering. We have an object that is moving along the positive direction of x-axis from point a to point b. Now this is the position at initial time, that is t is equal to 0. This is the final position at time t. Now initially the velocity is u, and at final point its velocity is v. So initial velocity u and final velocity v. The motion of this object is such that it has a constant acceleration small a, and s is the displacement between the two positions. So this is the displacement that object traveled. So s is equal to the displacement between point A and B. So now we are going to derive equation number first, and for this we are going to use the definition of acceleration. So acceleration was the change in velocity upon time taking. That means the rate of change of velocity. So we know that acceleration is equal to change in velocity upon time taken. Now left hand side is acceleration, so this is a. Acceleration is equal to change in velocity. Now change in velocity means final velocity minus initial velocity, so that is v minus u, and total time taken is t, that means final time minus initial time, t minus 0. On solving this we get a is equal to v minus u upon t, and on rearranging we get at is equal to v minus u, or v is equal to u plus at. This is the first equation of motion, and this equation shows the velocity time relation. This is the velocity time relation and is first equation of motion. Now moving to the second equation of motion. For deriving second equation of motion, we are going to use the definition of average velocity. So we know that the average velocity of an object is given by the displacement upon time. So if we are talking about the time interval 0 to t and we want to find the average velocity in between this time interval, so it is the displacement in this time interval upon time taken, upon this time. So average velocity is equal to displacement, the displacement between the initial and final position upon time taken to cover that displacement. So it can be given as V average is equal to, displacement is S, we consider it as S, and time taken is t minus 0 or t. Okay, so this we know that S upon t is the V average. Now we can also write it as S is equal to V average into t. Now if we talk about V average or the average velocity, we can also find it by taking the average of initial and final velocity. So we can also write V average as the average of initial and final velocity. So it will be initial velocity plus final velocity upon 2. So initial velocity is u, final velocity is v, and this is 2. This is V average. Now we have two values for V average. V average is equal to S upon t and V average is equal to u plus V upon t. Either equate these two, we can say it like this, or we can also say it like this कि V average का value यहाँ से हम इस equation में substitute करेंगे. So by doing that, what we get, S is equal to u plus V by 2 into t. S is equal to u plus V by 2 into t. So S is equal to हो गया u t by 2 plus v t by 2. Now the answer we need is S is equal to ut plus half at square, but there is no acceleration term. So to get acceleration term, we have to remove this v, as the formula, the equation we need doesn't contain v but it contains a. So by using first equation of motion, v is equal to u plus at, we are going to substitute v is equal to u plus at here, and by rearranging that equation we can get the final answer. So what we have is S is equal to ut by 2 plus vt by 2, and by using first equation of motion, that is v is equal to u plus at, by substituting the value of v here, we get ut by 2 plus u plus at into t by 2. On solving this, we get ut by 2 plus ut by 2 plus at square by 2. So on adding these two terms, we get S is equal to ut plus half a t square. So this is the required second equation of motion, and it gives us displacement time relation or position time relation or distance time relation, right? So this gives us distance time or position time relation. Now moving to the third equation of motion. Third equation of motion is v square minus u square is equal to 2as, or v square is equal to u square plus 2as. To find or derive this equation, we are going to use two separate relation. First is the first equation of motion and second is the formula for average velocity. So first we need first equation of motion, and we know that from first equation of motion we have v is equal to u plus at, or we can write it as v minus u is equal to at. This is equation number 1. I am taking it as number 1 equation. Now from the formula of or definition of average velocity, we have average velocity is equal to displacement upon time, right? Now v average को हम लिख सकते हैं initial velocity plus final velocity upon 2, and displacement upon time is s upon t, right? So from this equation u plus v is equal to 2s upon t. This is equation number 2. Now to get equation number 3rd, I am going to multiply equation number 1 and 2. So this is v plus u and this is v minus u. Multiply equation 1 and 2. Why I am doing this? Because I need v square minus u square, and if I get v plus u into v minus u, it will be v square minus u square. So multiplying equation 1 and 2, we get v plus u into v minus u, and it is equal to v plus u is 2s upon t and v minus u is at. So t and t cancel, it is 2as, and left hand side will be v square minus u square is equal to 2as. So this is the 3rd equation of motion. Now moving to the 4th one. 4th one, as I said, is the modified version of second equation. In second equation we find s, that is the position of the object or the distance traveled. Now we are going to find the distance covered in a particular second by using equation number 4th, right? Equation number 4th is s nth, its left side is s nth, that means distance covered in nth second is shown by the equation number 4th. So to solving this, what we do, we find the distance traveled till nth second, the distance traveled till n minus 1th second, and then we find the difference. So we get the distance traveled in particular nth second. So this can be shown as, suppose a particle is moving like this along positive x direction. This is the origin. This is the position of the particle at time n minus 1, and this is the position of the particle at time n. So the distance covered by the traveled by the particle in n minus 1 seconds is this much, and distance traveled by the particle in n seconds, in total n seconds, is this much. If I talk about nth second, so this much distance is the distance that is traveled by the particle in particular nth second. So this is s nth. From equation number 4 we are going to find this. So how we are going to do this? We use equation number 2 for this. We write its value for Sn minus 1 for Sn, and then we subtract Sn minus Sn1 to get the Snth, right? Sn में से Sn minus 1 को हम subtract करेंगे and we can get the value Snth. So from second equation of motion, Sn minus 1 is equal to un minus 1, that is ut, plus half a t square. T is n minus 1, right? Now this is equation number 3rd. Now this is the distance traveled in first n minus 1 seconds. Now I am talking about distance traveled in first n seconds. The distance traveled in first n seconds will be un plus half a n square. This is equation number 4, that means t is equal to n. Now we have to subtract these to find Snth, that means the distance covered in particular nth second. Hence distance traveled in nth second, S nth, is equal to Sn minus Sn minus 1, and by substituting the values from 3 and 4 we can get this. So Snth is equal to U n minus 1 Un. First I have to put Snth, Un plus half a n square, this is Sn, minus Sn minus 1 के लिए Un minus 1 plus half a n minus 1 square. So we have to put these values from equation number 3 and 4 and solve this to get the required answer. While solving this we get Un plus a n square upon 2 minus Un plus u minus half a n square minus a by 2 plus a n. We will expand this n minus 1 ka whole square. On solving this we get these terms will cancel out, and the remaining terms that we get are Snth is equal to u plus a by 2 and an, so u plus an minus a by 2. By taking a by 2 common from the last two terms we get 2n minus 1. So this is the required equation of Snth. This is the required fourth equation of motion that gave us the distance covered in particular nth second. Suppose I am talking about the 10th second, so I put n is equal to 10 and here n is equal to 10 and we get the required answer. So these were the four equations of motion that we use in our numericals and practical purposes while dealing with the problems of kinematics. That's all for the video. In coming videos we will derive these equations using calculus method and graphical method. So for that, stay tuned and stay safe. Thank you.